Okay, we are working on writing and evaluating algebraic expressions. We have probably spent a couple of days just evaluating expressions and making sure that we understand these things. We're coming back to review how to make these expressions. So, we're going to be on, I believe, for my regular 7th, it's 202. For my accelerated class, your page numbers are going to be different, but we are working on evaluating and writing expressions. So in this case, we're going to go ahead and read it first to make some understanding of what we're doing. It says a full grain silo, well, the thing on the right, the picture, is the silo, empties at a constant rate. So I'm going to underline or highlight, you guys are probably going to underline, empties. So that means subtract. Remember, if I write it, you should write it. At a, and there's another hint word, constant rate. So that means it's going to keep emptying in a constant rate. It's going to keep happening. And it tells me that rate is 3.5 feet cubed per second. Write an expression to determine the amount of grain left after S seconds. So we have S that we're going to be using. So this is not an equation. We won't be able to solve it, but we can say how much is left. So we have the information that this is what we start with. And that is going to change, but what we start with is not going to change. The rate itself is what's going to cause the change. So let's make sure that that's clear and understandable. The 3,000, the capacity is always going to be the capacity of this silo. That is why we start that as, and I hate the word that they use the constant right there. That's why that is our constant. That is what we start with, so that number stays the same. So 3,000, and since it's going to be empties, okay, empties means subtract. So I'm going to go ahead and subtract. Now, what am I subtracting? Well, I am subtracting something for an amount of seconds. Well, that would be a rate per second. So 3.5 per second. So my ultimate goal with this is to make sure that you guys understand when you read these problems and try to create the word problem or the expression that goes with it. What do we start with? And how does it change? How it changes involves the variable. So that is what we're going with. We start with the 3,000, and it's going to change because it is losing 3.5 feet per second of that grain. So I'm trying to make these word problems as simple to put together as you can. Okay, so now we're going to go ahead and we're going to do number 20. If you needed to pause the video, you should have paused the video, but I know that you know how to go back. All right, this one is Joe bought G gallons of gasoline for $2.85 per gallon and C cans of oil for $3.15 per can. Well, this again has got some help for me. G gallons goes with the cost. So those two go together. C cans goes with the cost per can. So obviously, it's saying what expression can be used to determine the total that they spent on gasoline and oil. So there's going to be a plus situation. And if he is doing $2.85, that goes with the G. And $3.15 goes with the C. Now here's where it gets a little tricky. It says Joe spent $15. He bought 2 cans of oil. About how many gallons of gasoline did he buy? So since we get to do about the word about, I'm going to figure out how much he spent on oil. So I don't need to worry about that 15 yet. Well, oil is about $3.15 times 2. So he spent $6.30 on oil. So how much money does he have left? $15 minus $6.30, $9.70. Press pause and talk about what do we need to use that $9.70 on, and how can we figure out how many gallons of gasoline, which is our overall question. How many gallons of gasoline did he buy? What operation are you going to use with that $9.70? Push pause, talk about it, then come back. Well, basically, he's got $9.70 left to buy gas. And gas, I'm going to say, remember, if I write it, you write it. So gas is, I'm going to say, approximately $3. So how many of these do I have in 9? Okay, and in my opinion, I've got about 3. So the answer to that would be 3. If you need to press pause to make sure that you have it, write it down, please do so. Otherwise, we're moving on to 21. Okay, 21 is another problem. The outside temperature was 73 degrees at 1 p.m. and decreases at a rate of 1.5 Fahrenheit each hour. What expression can be used to determine the temperature H after 1 hour p.m.? So since it says rate per hour, that is telling me this makes the change. So it gets the variable. Okay, so it starts at 73. That means this is our start, and we'll call that our constant. Okay, so 73, and I have help. Is it going to be adding or subtracting? Push pause and discuss if you need to, but I see where it says decreases, so I'm going to say subtract. And the 1.5 we have talked about before goes with the variable. So 1.5 times H. Now, hopefully we have made these a little bit easier for you. You should not have too many problems doing with these things. And I think there are a few problems left over on these pages that you are supposed to do, but we did do most of them together. If I'm doing the consistent things, 19, you do not have to do. It's higher order thinking. You've already done 15 and 16. You've already done 14 and 13. If you have not completed these, those are the ones that you're going to be completing. And I will talk soon.